Hello all. Welcome to session 36 of the PySpark series. So in last, basically what I have done is for the lead window function that we have learned. Okay. For that, I have created two sessions. Okay, because one session was getting little longer, so I have kept one session for PySpark and one session for um, Spark SQL. Okay. So this becomes the session 36 of the PySpark series. Okay. Now, in last session, what the same problem is same. Okay. What we have to find is we have to find the customers and order IDs where order is cancelled after it is out for delivery. Right. Problem statement is the same. In the last session, what we did is we found the next order status. Okay, for example, confirmed is the next order status for a placed. Shipped is the next order status for confirmed. And what we did, we just filtered the orders where current like order status is out for delivery and next order status is cancelled. Okay, and for that, let's say for this one, for this customer and order combination, cancelled has no next order status, so the next order status for this row we got it as null. Right. Now there is one more way to solve the same problem. Okay. um what is that problem? So we have seen, like, we have lead window function which gives us the next, I would say, the next event of anything, next order status, or next location or something like that. Okay. We have one more window function, we call it lag. Okay. Lag from it, a pure English meaning also, it says it will give the previous. Okay. So in last session, what we have did is we have found out the next order status. In this session, what we'll do, we'll just find out the previous order status. For example, previous order status to cancelled. Okay. And wherever my previous order status is out for delivery and the order status is cancelled, that is my set of results. Okay, fine. So we have data already. I will keep this data in the video description. Okay, we had created orders df1. So if you recall, we just did the cast. So we read the date as string and then we casted that to date, right? So out of df1 we have ready. Okay, we'll directly go, and what we'll do, we will define a window, right? So to define the window, what I have to do, I have to import the window. Okay, from pyspark.sql.window import window, right? Fine, window is imported, right? Now let me define the window. For example, lag window, I'll name it as lag window. Okay, window dot partition by. Okay, which columns I have to use in partition by? Customer ID and order ID. Okay, so what I'll do, F.col. Okay, this is the programmatic way of writing the code. Okay, this is how generally we write in projects, keeping in the perspective good coding standards. Okay, F.col. Sorry, it is not customer, it is customer ID. Okay, customer ID, and next column is what? Order ID. Okay, order ID. Okay, and order by what? Order by using, sorry, order by. Okay, which column I have to use? Status date. Okay, order by, let's say F dot asc. Okay, F dot call. What? Sorry, sorry, it's not this, it should be a column name, right? Status set. Let me run this. Okay, so I have defined the window. Fine. Now what I have to do, I have to apply lag function. So what I'll do, I'll chain all the transformations here. Okay, I'll not write separate data frames. This is how we done in actual project. Okay, how we do in actual projects. Okay, so orders df1. Okay, what I have to find, in last session we found next order status. In this session, what we will find? Previous order status. Okay, previous order status. So can you guess, this cancelled had no next order status. So for this cancelled line, it gave null. Now it's time for placed, because for placed, for this order ID and customer ID combination, there is no previous order status. So for placed column, for a row where we have placed order status, for this customer ID and order ID combination, we will get null as previous order status. Okay, let's see that. Okay, just we made a guess, what based on what we learned from previous session. Okay, okay, fine. So what I have to do, f dot lag. Okay, lag on which column? Order status. Okay, let me see if I can use f dot call here. I should be able to. Order status, right? Okay, dot over which window? This window, right? Lag window. Okay, let me run this. Okay, results TF is successful. You can see we have used f dot call here. Okay, let's just display. So generally in live projects we don't display much. We generally don't display at all. Okay, here we are doing just for learning, uh, just to see the data. Okay, so as we guessed, you can see placed has previous order status null, because there is no previous order status for this customer ID and order ID combination. Okay, fine. Now from these, what I have to filter. Okay, what I have to filter, order status as what? Cancelled. Okay, and previous order status as out for delivery. Okay, last session we kind of uh, made a mistake here, right? But we corrected that then and there only. Okay, so filter. So here I have two filter conditions. Let me wrap entire filter condition into one bracket. Okay, so f dot call order status. Okay, order status equal to what I'll use, f dot lit cancelled, right? Is that right? No, this bracket I have to close here. Okay, here, so that my one condition comes into a separate bracket. Okay, let me copy this itself. Okay, now what I have to do, I have to use and. Okay, f dot call order status, f dot call previous order status. Now I have to, no, I don't have to filter. I have to copy the column name. Okay, copy column name. What previous order status I want? Out for delivery, right? Copy out for delivery. Okay, let me run this. Fine, let's see the results. Okay, see, same 1 2 3 6 and 5 9. Did we get some results using lead? See, 1 2 3 6 5 9, same, right? Okay, results should be same from both. Okay, and now what I have to do, I have to select two columns. Okay, as per my requirement. Which column I have to select? The first is customer ID, customer ID. Okay, and second is order ID, right? Let me run this. This should be a quick session. Okay, fine. We have got the results, right? In last session, if you remember, we got one error over here. Here, okay. What mistake we did? I'll just show you. Okay, just for a recap. Okay, what I'll do, I'll just copy this code. Okay, just for a recap. Okay, what I'll do, I'll just, yeah, results df. Let me do maybe df1. Okay, df1. Let me not put these conditions in separate brackets. Okay, let me put them open. Right now, if I run this, see, it has given error. Cannot convert column into boolean. Please use and. Okay, so this is like when you are giving a multiple, you know, filter conditions. if you have to like make, I would say, um, and or, okay, the same way that we used to do in mathematics, okay, just specify each filter condition in separate bracket. Okay, so what I have done, I'll select this and I'll just add bracket. Okay, this should be successful, right? This was the mistake we did. Just have a look. If you get this error, this is the trick. This is the way to resolve this error. Okay, fine. Um, Next, now let's solve this using you know, Spark SQL as well. So Spark SQL, I think we have encountered many errors in last session, right? We will recall those also, okay? Because it is definitely a satisfaction to resolve the errors, and also if we recall them, if we get them while working, right, we will not spend much time on analyzing what is there and how to solve that error. Okay, fine. So Spark SQL, as you know, we will need to solve this? We'll need to solve this using CTA. For multi-line, what do we do is we specify three quotes. Okay, T1 as, T1 as, select, I can give star, I want all columns. Along with that, what I want? Lag. Lag based on what? Order status. Okay, as previous order status. Okay, sorry, it's not like this. I have to specify window, right? Over, right? And window. What is window? Partition by customer ID, order ID. Okay, order by what? Date, right? What is that column name? Status date. Okay, order by status date, ASC. You specify or you don't specify, that is fine. Okay, adds previous order status from orders. Okay, fine. Now let me select star, select star from T1. Okay, and what I'll do, I'll just write display. Okay, fine. Okay, now in last session while learning lead, what we did, we just specify the filter directly here. Okay, what that did was that filtered, okay, for example, out for delivery, it filtered out for delivery, right? And to out for delivery, there was no next event for this customer ID and order ID combination. That's why we were facing few issues, right? But we got to know, we got to learn something out of that error, right? Fine. What I have to select here, customer. Now final result. Let's look at final result. Okay, customer ID, order ID from T1. Okay, where order status, order status equal to what order status I want? Cancelled, right? Cancelled. Order status cancelled, and previous order status equal to out for delivery, right? Order status equals to out for delivery, right? Let's run this, right? Same results 1, 2, 3, 6, 5, 9, right? Okay, fine. So this is how we work with lag. So in this session, we have also recalled what errors we faced, okay, when we were uh, learning, okay, when we were working in last session while learning the lead, right? Fine. Now, just a quick, quick note. If there is any performance difference between lead and lag, okay, in PySpark. So there is not huge performance difference, okay, when we work with lead or lag, but there is a minor performance difference. Okay, lag is generally little faster than lead function. Okay, the reason being, Generally, Spark processes data in, line by line. Okay, it processes data line by line. For example, here if you see here, it will first, compute this line, then the next line. Okay, so it processes data line by line. Okay, what lag function does is it compute the value by checking at previous rows. Okay, on the other hand, what lead does, it looks at, next rows, right? So generally, as Spark processes data in linear way, looking like I would say, processing data by taking reference of previous row can be little faster. Okay, that is one thing. And it is, I think it is there, that's Catalyst. There is optimizer. Spark internally has an optimizer. So Catalyst optimizer can optimize lag expression more effectively. Okay, it's not that, okay, that I would say a notable performance difference, but there is a negligible performance difference. Okay, so wherever you can use lag, okay, scenarios, that will be maybe can prove a more performance efficient if you have, huge amount of data, right? Fine. That the I think that everything about lead and lag. Okay, so I'll just mention here, okay, what I've got to know about performance difference. Okay, performance difference difference between lead and lag, right? So first is lag processes data by looking at previous rows, right? As Spark work in linear fashion, okay, lag can be prove more performance efficient. Okay. Second, second point what we discussed is the don't worry about catalyst optimizer as of now. It is the internal optimizer, okay, that Spark has. What that optimizer does, okay, what are the default optimization techniques that it applies, we will see going ahead. Okay, but just as of now, just understand the catalyst. Okay, the catalyst optimizer, the internal optimization of Apache Spark optimizes, okay, lag expressions little faster, okay, than lead expressions, right? Okay, fine. So good. I think this is also interesting, right? Why the performance difference between lead and lag, and why lag is little more performance efficient than lead, right? Fine. Great. That's everything for this session. I think we have covered all the, aggregations. Now we have covered simple aggregations, grouping aggregations. Okay, in depth, I think we have learned around. I think we had how many sessions on aggregations? Let me just see. Simple simple aggregation. Okay, so we started in session 21, right? Learning simple aggregations, and where we are at session 36. So around 15, 16 sessions we spent in learning aggregations, because definitely aggregations have got that much weightage when we work with PySpark or SQL, right? And we have covered in depth. Okay, fine. That's everything for this session. If you feel this is useful to the community, do like, share, subscribe. Okay, and if you feel, like if you feel there is some feedback that you want to give me, right, you want some improvement, or you want you're liking these sessions, do let me know in comment section, or do ping me on LinkedIn. Okay, fine. That's everything for this session. I'll see you in the next session. Thank you so much.